given two three-phase resistive loads fed from a balanced 120 volts 50 hertz three-phase 4-wire supply as shown in figure. Okay, calculate the neutral voltage and current. Now what is neutral voltage? Vn. Vn is equal to, I can write it as In into Zn. Okay, since this is solid type neutral, okay, what is solid type neutral? It does not have any reactance or resistance. So Zn is equal to, so Zn is equal to 0. Okay, if Zn is equal to 0, what is neutral voltage? Vn. In into 0. So neutral voltage is 0. So only two options are possible here, B and C. Now we have to find neutral current In. What is neutral current In? In is equal to Ia plus Ib plus Ic. Okay, generally it is given as minus of Ia plus Ib plus Ia plus Ib plus Ic. Generally this is equal to 0 for balanced supply. Okay, not equal to 0 for unbalanced supply. Okay, this is for balance. Now what is Ia? I can write In is equal to, Ia is, since this is resistive type load, okay, I can write this is Va bar by R An plus Vb bar by Rbn plus Vc bar by Rcn. Okay, now what is Va? Va is, he has given supply voltage as 120 volts at an angle 0, since this is A phase, or you can write it as R phase. This is R phase, this is for Y phase, this is for B phase given in question. Okay, now what is VR or Va at 120 at an angle 0 by RA? Okay, since this is line voltage, we have to divide it by root 3 to get phase voltage. Okay, into RAN is, this is RAN, or we can write this one as R phase, this is Y phase, and this is B phase. Similarly, you can write this as A phase, B phase, and C phase. So 120 by root 3 is the phase voltage into RAN is 10 volts, plus similarly 120 at an angle minus 120 by root 3, that is phase voltage for Y or B phase. RBN is 2 ohms. Similarly 120 at an angle minus 240 by root 3 into 2. If you calculate this one, you will get it as minus 28 ampere. So option B is correct answer.
Capacitor start single phase induction motor is shown in figure. Okay, now this is a capacitor start single phase induction motor. We have to calculate power factor of the auxiliary winding. Okay, he has given this as an auxiliary winding, this as main winding. Okay, when you have auxiliary winding and main winding in single phase induction motor, always the phase difference between main winding and auxiliary winding flux is 90 degrees. Okay, this is the phase difference between main winding and auxiliary winding. So now what is the phase angle for the main winding? Tan inverse of reactance by resistance, this is equal to 1. Okay, since it is equal to tan inverse of 0.5, so what is phi? Phi is equal to 45 degrees. Now let us take, if you have a voltage applied across the single phase induction motor V as in this direction. Okay, now what about the main winding? Main winding current is lagging behind the voltage by 40 degrees. Now where will be the auxiliary winding? Auxiliary winding should lead by, current should lead by this 45 degrees. Now what is the phase angle difference between auxiliary winding and main winding? 90 degrees. So power factor of the auxiliary winding cos phi should be equal to cos 45 degrees, or you can write it as cos 300 and what is that value? 360 minus 45 is 300 and cos 360 minus 45 cos 315 degrees. So option D is the correct answer.
He has given a single phase 440 by 220 volts transformer. Okay, this transformer frequency is 25 hertz. Okay, this is operating at 25 hertz. Calculate the frequency reference signal such that transformer will set up rated flux in the core. Okay, now if you see here, we have to calculate the frequency of the reference signal. But okay, this is sending a reference one from the input side. Okay, output frequency is 25 hertz. We have to calculate what is the frequency at the input side. Okay, to set up rated flux, phi is directly proportional to V by F. So I can write this one as V1 by F1 is equal to V2 by F2. Since I have to maintain this is as rated value. Okay, now from this, okay, I can write F2 is equal to F1 times into V2 by V1. Okay, what is F1 value he has given? F1 as 25 hertz. Okay, input voltage is 220 volts and transformer input voltage is 440 volts. Okay, this is equal to 25 into 220 by 440, 12.5 hertz. Okay, what is this frequency controller? This frequency controller is nothing but he is using one cyclo converter. From cyclo converter, what we can do, we can control output voltage as well as frequency. That's why here the input voltage of transformer is doubled when compared to the AC input supply to 20 volts. And you can also maintain frequency a controlled variable as a controlled variable. So option is 12.5 hertz, that is A is correct answer.